is what I call the full comparison sentence for two sets of data. Now, it's a very popular question in the GCSE to give you two sets of data from which you crunch some box and whisker plots, and I might give you two of them. Oops. And there'll be a scale attached, so maybe this is 10, this is 20, 30, 40, 150. And they say use the data to make comparisons of the situations that led to these box plots. Now, it's not infrequently the case that not only will you have these box plots, but you also have some additional figures that you had to work out. So, for example, maybe you worked out the mean somehow. And so, for example, let's imagine that the mean for this one was 70, whereas the mean for this one was 50. Now, and your job is to make comparisons of the two data sets. Now, I'll just remind you what the box and whisker indicates. That's the minimum, that's the lower quartile, that's the median, that's the upper quartile, and that is the maximum. Okay, so that's minimum, lower quartile, median, upper quartile, maximum. Let's pretend for the sake of this example this was about two cricket teams, and the figures that got put into the data were just the averages of all the batters across the season. So your comparison sentence would look like this. You've got to link it back to the situation. So let's say this was team A and this was team B. So you say something like this. Team A is stronger at batting on average than team B. Now, why is that? It's because their mean is higher. So mean 70 versus 50. But then you acknowledge that that's only the case on mean. On median, team B is better. Now, why is that? Because the median is about 60 versus 40. Now, they always want you to say something using the average, which I've used median and mean here because they're both available, and it's perfectly okay to acknowledge that they pull in different directions. On median, team A is stronger, and on mean, team A is stronger, but on median, team B is stronger. Now, they want you to make a comparison using average, but they almost always want you to make a comparison using spread. Now, in the world of sport and most other things, we generally accept that the more consistent it's, the better. That means that the more varied the data set, the weaker the performance is. So you could say, however, the performance of team B is weaker as it is more variable. And then you say range, the range of this is 160 minus 10, whereas this is 150 minus 20. So that's why it's weaker, because its performance is more varied. But again, you acknowledge that that conclusion is only on range. On interquartile range, it is the other way around. Team A is more variable. What are the interquartile ranges? 80 minus 30, so that's 50, whereas this is 80 minus 35, which is 45. So that is the full comparison sentence for two sets of data. It's actually more than one sentence. But the crucial things are these. First of all, I think there are four crucial things. First of all, we've linked it back to the actual thing. We've talked about batting and being strong at batting. We haven't just talked about data, we've linked it to what the data means. We've covered both average and spread. So we've got the average figure and also the measures of variability. We've acknowledged that the measures used for average and spread pull in different directions, and we've used all figures available to us that we can. So we had mean and median for the average, and we've got range and interquartile range for how spread out the data is. So that is